Okay, so I don't know where I left off, where it's cut out, so I'm going to go back to number 8 because I don't think I explained it well. So number 8 should be C, because a block is pushed to the left into a spring and then released. So it's pushed. So so in the graph it should start. They all start at the same place, but it's pushed. But since it's 1/2 kx squared, spring constant, it's exponential. So it should go down exponentially. So automatically D and B should be out. But then as you see, the second part, it says it compresses a spring with half the spring constant till it pauses. So in the second part, this part should be 1/2 of what the slope is in the first part. So if you see that in A, or if you see that in the potential energy part, the first part should be twice as steep as the second part. And then this goes with this, obviously, like there's not going to be anything wrong there. So it should be C, because that's what describes C. Okay, and the number 9, it's conservation of energy again, which is right here. So it should be 1/2 kx squared equals 1/2 mv squared, which then this shouldn't be 1/2 mv squared, it should be mgh. But anyway, so it says if the spring was compressed 3 times as far as in the third trial, block would leave the spring with, so the first part is still going to be 3 times because it's spring constant, so it's telling you. But then it goes into where I wrote it, 1/2 mv squared right here, because then it is k. Yeah, because then it's 1/2 mv squared. So it should leave the spring with 3 times the speed because it's compressed 3 times as much, but it should reach a height of 9 times because the velocity squared. So it's v squared. So the answer should be D. And then I move on to number 10 right here. So the equation should be K initial, or K, it should be the kinetic energy, the first one, plus the G equals kinetic again, but the second one, and then G2, and then plus 4,000 joules that it says are lost. So you have to put the 4,000 joules on the right. And so the equation should be 1/2 times mass, which is 300, times velocity squared, which is 4 squared, plus mass again, 300, and then gravity, which is 10, -10, and then height is 20 at that point. And then when you move on to K1, it's still the same mass, but the velocity is now 7.3 here, and then plus mgh again. You're trying to solve for this h, and then plus the initial 4,000 joules that are dissipated from the left side. So if you do all this out, it ends up being h equals like 16.8 or 16.7 something, I forget what it is, but it ends up being around 16.8. So that's why the answer should be A, 16.8. Okay, now we move on to 11. 11 I still don't really know how to do, but I know that on C part, on C, when it's decreasing G, it should have been increases as you wrote right here, not has no effect. And that's because if there's decreasing G, then when it gets to the top, it doesn't have to like work so hard against it. So it's actually increasing speed because there's not as much gravity pulling down on it. Yep. Okay, and now we move on to 12. So for 12A, I had negative